Welcome back, and here we are now going to be working in 7.4, which is the last section that will be working on proofs. Specifically now we're going to be learning how to do conditional and indirect proof when it comes to statements expressed in the terms of predicate logic. And so I'm going to start with this argument right here, and in working on this I'm going to be able to illustrate the one and only new bit of information here when it comes to doing conditional and indirect proof in predicate logic. So the good news there is that really there's just one little new thing to learn, and otherwise conditional and indirect proof will pretty much run the way they did back in chapter 6. So what we have here is a premise, and it says there exists an x, ax, and then the conclusion for all x, ax. And what we might think about first here is if we have the opportunity to do conditional or indirect proof, we need to decide which technique to use, right? And I just want to make sure you understand that on the last exam, this is how the proofs in this particular area will be presented. In other words, the instructions will say you can use conditional or indirect proof on a proof. You decide which technique to use. So we did talk about this back in chapter 6, but just as a reminder, what you want to do to determine which technique to use is you want to look at the conclusion. And if the conclusion has a horseshoe, right, in it, then you want to go with conditional proof, or possibly a triple bar, right? But those are the two prime candidates for doing conditional proof. If you have any other kind of conclusion here, as we do in this case, you want to go with indirect proof, all right? So in this case, we definitely want to go with indirect proof because, again, there's no horseshoe here in the conclusion at all, or a triple bar. So there wouldn't be any obvious way to set up a conditional proof for this one. So once we've decided to do indirect proof, you'll remember that what we're going to do is indent, and we're going to make an assumption here, an assumption for indirect proof. Now, back in chapter 6, what we did, of course, was we would assume the opposite of the thing that we're trying to get. So if we're trying to get for all x, ax, we would assume tilde for all x, ax, right? That would be our typical traditional assumption. And I just want to make this clear. That is the assumption I would encourage you to use here if we're going to do an indirect proof with this one. Having said all of that, we're actually not going to make that assumption. And that is simply so I can make the particular point I need to make about conditional indirect proof here when we're working in predicate logic. So in fact, the assumption I will make is tilde ax, okay? And so this is an assumption for indirect proof, and you'll remember that when we make an assumption for indirect proof, we're trying to get a contradiction. All right, so just to emphasize here, don't take this as your typical kind of assumption that you would make when you're doing indirect proof. I'm making kind of a little bit of an exception here, or a different kind of assumption, again, just to make a point that I'll be making here in just a couple minutes, all right? But setting all that aside, you know that when we do indirect proof, right, we make this assumption, and then as we saw in chapter 6, I try and use my assumption right away if I can, right? I try and use it right away. Well, of course, 1 and 2 here, I mean, they're not working together, so in terms of using this right away, these two are not really going to be doing anything exciting together because they're just fairly short statements. So we can also consider, of course, adding or removing quantifiers, right? We've done that before. And we could consider perhaps removing this quantifier because it is the main operator. Or we could consider adding on a quantifier here as well. So let's say we went ahead and added on the universal quantifier to line 2, right? Remember, as we discussed earlier in chapter 7, since we have a variable here, right, it seems like it's at least possible to do that. So we end up with this. Now we'll remember that our goal is to get a contradiction, something and then the same thing with a tilde in front of it. Well, 1 and 3 here are not a contradiction yet. We need to match the quantifiers, right, to perhaps accomplish that. So we'll remember the quantifier negation rules, which allow us to take that tilde and move it to the other side, like so, right? Took the tilde and moved it to the other side. Now I think it's pretty clear with 1 and 4 we have a contradiction. And so remember, when you're doing indirect proof, you are almost always, at least, going to need to take a step where you do conjunction and join the two parts that are, in fact, contradictory. So that's 1 and 5, right, that we're conjoining there. Okay, so we end up with this, and that's our contradiction. So here's where we get a good chance to review indirect proof. Once you get a contradiction, what you do is you simply unindent, and then you go back to your assumption, and the procedure here is always the same. It's always the same with indirect proof. Once you get your contradiction, you unindent, you write down your assumption. And then, don't forget, then you put a tilde in front of that assumption. And that's indirect proof, lines 2 through 5. We end up with this. Now, of course, that's not our conclusion, right? We know that. But as we saw in Chapter 6, doing indirect proof, we often have to take a step where we double negate. So double negate, get rid of those two tildes. We still don't have our conclusion, but of course, the only difference between line 7 and our conclusion is the introduction of the universal quantifier. And since we have a variable here, we can do that. And so there's our conclusion. It matches. And this, again, I hope gives you at least a bit of a reminder as to how indirect proof works, okay? Now, here's the thing. I didn't actually tell you anything new here. And here's what I need to emphasize that is new when it comes to predicate logic and doing conditional or indirect proof. And we can recognize that there's something new going on here when we actually look at what we've just proved. Okay? So the premise here is there exists an x, ax. And that could mean something like apples exist, right? Apples exist. Well, what have we concluded from this claim that apples exist? We've concluded that every single thing in the universe is an apple. So this is not a valid argument, in other words. Something clearly went wrong here. We should not be able to conclude that every single thing in the universe is an apple from the fact that apples exist. Yet it seems like all of our steps are correct. However, there is this one new stipulation when it comes to doing conditional and indirect proof, and we're dealing with predicate logic like this, and that is this. Line 3 here is not allowed. In other words, I'll put it right here. I have a lot of room. Okay? Here's the thing. There's a new restriction on doing conditional and indirect proof. You can't do UG on an assumed free variable while you're indented. So you can see here in line 2, we assumed tilde AX. And when we assume tilde AX, that X, of course, is a free variable, right? There's no quantifier that applies to that variable. So what we are needing to understand here is that when you assume a free variable, you can do that. You can assume a free variable. However, when you do that, you can't do UG on that free variable while you're indented. Now, this instance of UG down here in line 8 is legitimate. It's okay because we're not indented anymore. So, you know, if you're thinking about, well, why can't we do this? Well, I mean, one way, the quickest way really to answer that question is because if we cannot do UG on an assumed free variable, then we won't be able to get from the claim that apples exist to the claim that every single thing in the universe is an apple, right? It's this step here, step 3, that allows us actually to get a contradiction and therefore get this conclusion that really should not be able to be gotten from that premise. So we will not do this step, and then, of course, an argument like this, we would not be able to get that conclusion from that premise, and that's a good thing. So, got a lot of words over here, right? And you might be thinking, well, this is something, you know, I'm going to have to remember, going to have to worry a lot about. But I do have good news for you. A couple things. First of all, as you will see in the subsequent videos when we're doing other proofs in conditional and indirect proof in predicate logic, many times you won't even assume a free variable. So you won't even have a free variable there. And in that case, you won't need to worry about not doing UG while you're indented. Secondly, even on the conditional and indirect proofs where you will assume a free variable, I can tell you that you will not be tempted to do UG on that free variable. So my point is, don't lose any sleep over this. Be aware of it, but don't lose any sleep over it. If you find yourself assuming a free variable, you can leave yourself a little note. Don't do UG while indented, and it'll take care of itself. You'll be fine. All right? But we'll go ahead now, and in the next videos, we'll look at some proofs which are actually valid, dealing with valid arguments unlike this one. You'll see how conditional and indirect proof work.